Ladies and gentlemen, hello and welcome back once again to the Synthesis webcast series. Your host here, Eric Cavanaugh of the Bloor Group. I'm so excited to be talking about one of the most critical and frankly, sometimes complex aspects of the whole data world these days. We're going to talk about hybrid integration, a blueprint for bridging on-premises and multi-cloud silos. We'll be hearing from Dave Wells of Eckerson Group and Nassir Khan from Informatica. And folks, I always try to remind you the best way for custom value from these events is to ask a question. So don't be shy. Use the Q&A component of your webcast console, or you can also chat me. Either way, Q&A is usually the easier way to go. And we'll try to keep some time for questions and answers at the end. But with that, I'm going to hand it off to Dave Wells. Take it away, Dave.
Thank you, Eric. Eric is absolutely right. This is one of the more complex things we deal with in data management today, because we've experienced this thing that some refer to as data sprawl, some refer to as application sprawl. The reality is, as we continue to go through this technology evolution, we'll see more and more of data and applications deployed to different kinds of cloud platforms. And today they're becoming silos, and what we need to do is figure out how to overcome the silo effect and get the value of a multi-cloud world, get the value of a hybrid world, while easing the pain of trying to manage data in that world. So data and application management in today's world is complex, it is challenging, and we continue to have the need for integration, both data and application integration, and that need grows while this trend toward cloud, multi-cloud, and hybrid makes the work of integration become increasingly complex. So a typical data and application landscape looks something like the diagram you see here, with many data silos, including multiple data warehouses. This is one of my recent findings when I speak and when I teach. I run live polls asking how many data warehouses do you have? 60% of respondents say they're operating between 2 and 5 data warehouses. Less than 10% say they're operating only 1. So that says 30% have 6 or more data warehouses. So we've got this sprawl of data warehouses. Now we've got sprawl across the cloud. We've got data warehouses. We've got data lakes. We've got lots of different application databases, including software as a service databases, which are cloud deployed. So the data is spread across many, many different platforms. In this example, you can see 6 cloud platforms, as well as on-premises databases of several types. Application silos and application sprawl are similar to what we've experienced with data, because we have software as a service, ERP, and legacy systems spread across multi-cloud and on-prem environments. So management and integration challenges are exacerbated with increasing volume, increasing variety, increasing velocity of data, combined with more users, more use cases, demand for more agility, and looking for the ability to respond quickly to changing business needs. The rapid response and the agility are difficult to do if we can't overcome this need to bridge the silos. So the simple data integration world of the past that may have seemed complex at the time, it no longer exists. It no longer meets today's business and information needs, and is no longer a practical way to step up to this. ETL-based data warehousing viewed data integration as a one-size-fits-all solution for harmonizing data. Remember that myth about the single version of the truth? I've not yet encountered anybody who succeeded at single version of the truth. And when we're having companies running 4, 5, 6 data warehouses, that's pretty much a signal that we didn't arrive at single version, and maybe it's unattainable. So with the variety of use cases that we have in modern analytics, that one-size-fits-all idea doesn't even work. We need different configurations of data for different use cases. So the many constraints of this old style of integration, using only operational sources, batch ETL processing with the inherent data latency, focus on relational databases, those don't step up to the realities we face today. Big data, fast data, exploratory analytics. So further constraints keep this approach from working well in this age of self-service reporting and analytics. We simply have to move away from the age of ETL and move into a world of modern integration. Modern data integration is substantially more complex than that old ETL world. In the age of big data and data lakes, we have more data sources. We have more kinds of data. We have more kinds of processing. We have more use cases. We have more kinds of data consumers and more kinds of data integrators. As data lake adoption grows, data warehousing continues to thrive, and the relationship of data warehouses and data lakes is a cause of uncertainty, a cause of complexity, and one of the drivers for people who are seeking to modernize their data architecture. So fast data, dynamic scaling, agility, and self-service top the list of expectations of data workers. If I'm someone who depends on data to do my job, I need that data fast. I need the data management environment, the analytics environment to scale to handle whatever workloads I throw at it. I need the ability to be agile, to discover requirements, to discover new questions, to adapt to changes on the fly. And I want self-service. I want to be able to go get the data myself, analyze it myself, and not be subjected to the backlog and the bottleneck that tends to exist with IT organizations today. So the variety of deployment platforms and the variety of processing technologies has exploded. And it really becomes unsustainable unless we pay attention to data knowledge, metadata management, and data governance, and all the pieces that it takes to glue all of this together and make this new complex world stop being one of silos and become one of practical integration. So if we shift from legacy data integration to legacy application integration, we see similar kinds of things. The application integrated techniques of the past are as outdated as those of legacy data integration. Pardon me, in an environment that mixes multi-cloud and on-premises application platforms, we operate with messy, spaghetti-like, handcrafted interfaces between applications. These interfaces use a mix of multiple methods. Sometimes it's synchronization, sometimes it's data feeds, sometimes APIs, sometimes messaging. And we do this without well-defined standards to guide which technique is appropriate for which integration needs. Often the approach to integration is defined by whoever is doing the development at the moment and what's the fastest path to get the integration rather than the most architecturally sound path. So application integration is complex and is further compounded with this mix of legacy, ERP, and software as a service applications. They have semantic inconsistencies, they have different methods of data encoding, and they have timing and schedule conflicts. So this is far from a resilient application world. It's a fragile world. It's maintenance intensive. It's easily disrupted by business and technical changes. And it's especially challenging when errors occur and we need to recover from those errors. So we need to shift from a legacy application world to modern application integration. Modern application integration has to unravel that spaghetti mess of crossing lines and arrows going everywhere. Step away from point-to-point integration and manage the realities of a complex multi-cloud and hybrid application environment. Simplifying the application environment isn't realistic and it isn't practical. We will continue to see growth toward more application sprawl. What we must do is simplify the methods that we use for application integration. In place of point-to-point application interfaces, we need a central place to manage application integration, a hybrid integration platform, or HIP. The HIP should enable anything-to-anything integration, cloud to on-prem, cloud to cloud, software as a service to ERP, SaaS to custom and legacy applications, and so on. HIP must readily scale to meet the workload, resource, and performance demands of all of these applications that are in play and trying to talk to one another. It should be dependency aware and manage dependencies among applications, incorporate standard integration patterns, provide seamless interoperability among application platforms and environments, and include the features that are needed to resolve semantic inconsistencies and encoding inconsistencies. Runtime orchestration is ideal because it minimizes the amount of human effort needed for continuous and reliable application integration. Reaching beyond enterprise boundaries is needed to enable business-to-business integration and application collaboration with business partners. Ease of use and resilience to errors and changes are important characteristics for anyone who implements and operates these integrated applications. So modern application integration needs to look substantially different than legacy application integration. On-premises is not going away. The cloud will continue to grow, and multi-cloud is unavoidable. The example you see here comes from a university that I'm familiar with, worked there in the past, and continue to have friends and be in touch with some of their ongoing projects at the university. They're moving from legacy applications from the 1970s, 80s, and 90s, COBOL mainframe applications, to software as a service applications. So in 2018, they made the migration from legacy payroll to Workday. What this did was put their payroll in the cloud, while everything else that interacts with payroll, HR, benefits, finance, everything else was still mainframe. 2019, they migrated legacy HR to Workday. So now I have HR and payroll in the cloud, in a cloud, and still needing to integrate with applications that exist on the mainframe. 2020, they're underway right now working toward migrating from legacy finance to Workday. And the finance migration in 2 phases will run through in 2021. Okay, so what's happening while all of this is going on through 2018 through 2021? We have HR, payroll, and finance, all of which have a high degree of integration need, a high degree of dependency. Not only are they partly on-prem and partly in the cloud, but the deployment is shifting as they work through this migration. So what was once on-prem is now in the cloud, and we have to rethink the integration with each and every migration. So as we continue this path and this plan to replace their legacy systems, they're looking at, in 2022, moving from legacy admissions system to something called STARS, which is cloud-based student systems with a cloud that is distinct and different from the Workday cloud. So they move admissions to STARS in 2022, they move education to STARS in 2023, and they continue to migrate beyond 2023. This constant shift to the cloud adds more clouds and more clouds and more clouds, and with each migration creates the need to rewire the integrations. And when we rewire the integrations by recoding point to point, it's fragile, it's labor intensive, and it's not building for the future. So that is just one use case for a hybrid integration platform. Some other common use cases: integration for mergers and acquisitions. M&A always brings systems that will need to talk to one another, that were not built to talk to one another, and to handcraft those integrations as point-to-point integrations is labor intensive, time consuming, error prone, and not very sustainable into the future. We see shifting to cloud to scale for growth or new lines of business. So we may migrate existing applications from on-prem to cloud simply to support growth and need to rethink the integrations as we move to the cloud. We have the business-to-business integration that I mentioned earlier. And one of the big ones is often we have workflows and transaction flows that span multiple applications that are now in this hybrid multi-cloud world. And if we can't get these applications to talk to one another efficiently and effectively, it affects the customer experience. Customers expect frictionless experience. I get online and everything happens as it should happen, with no concern about where the applications that support it reside. So lots of use cases for hybrid integration platforms. These will continue to grow. It's not going to get smaller, it's going to get bigger. HIP is important for meeting today's complex data and application integration challenges. It's important today, it will quickly become essential and indispensable to meet tomorrow's needs as we experience increasing demand for more integration. We'll experience more data sprawl, we'll experience more application sprawl, we'll experience accelerated growth in the variety of users and use cases. We'll see continuing evolution of data, continuing evolution of applications, and continuing evolution of technologies. If you're not already there, you will soon experience the urgent need for smart integration technology. And you may want that smart integration technology to be supported by an integration center of excellence. Integration, both data and application, is a modern business imperative. It is fundamental to digital transformation. So we see many organizations now stepping toward this idea of an integration strategy and execution team, ISET, that focuses on data integration and application integration and business process integration. And as we see more of the mergers and more of the partnerships and more of the acquisitions, the demand for integration grows and the value of ISET grows in a corresponding way. So I've mentioned HIP several times now. What is a HIP? A hybrid integration platform is a framework that supports all integration use cases for all types of data and applications. It supports seamless integration of data and applications across multiple platforms, any combination of cloud and on-premises, without requiring that the integrator know the locations and the technologies. There are 5 must-have capabilities for HIP. A good HIP platform must support any user from citizen integrators to tech-savvy specialists. A good HIP must support data at any location, structured or unstructured, and stored or streaming. We need support for any data integration pattern from batch ETL to real-time streaming, change data capture. For all application integration patterns, all integration patterns, including integration among software as a service, ERP, legacy systems, as well as B2B integrations. We need support for multi-cloud and hybrid integration with extensive cross-platform capabilities. And we need AI and machine learning for smart integration and for automation and orchestration. So as I said, in the definition of HIP, it is a framework that supports all integration use cases. This diagram is a big picture view of the framework with components that range from business to technical, from use cases to metadata, all within the boundaries of administration, governance, operations, and orchestration. With the next few slides, I'll step through those components in a bit of detail so that you can see how they all fit together. Starting with business use cases, data science, analytics, business intelligence, and reporting applications, and B2B and B2C communications all depend on data, and they all frequently need to integrate data drawn from multiple sources. Ultimately, business applications are the means by which data produces value. Both data and application integration have important roles in producing and creating and delivering business value. The data and integration stakeholders comprise the many different roles in data consumption and data management, each with opportunity to gain agility and gain advantage through HIP. Data scientists, data analysts, and data engineers use HIP to break down data silos and blend and harmonize data deployed across multiple platforms. Citizen analysts and integrators are able to bring together data and applications without the struggles of cross-platform integration. Architects and application developers have newfound freedom to choose the best fit platform for each deployment without assuming technical debt for future integrations. Business leaders are able to leverage the full scope of enterprise data and applications to drive insights, innovation, and digital transformation. We move into the data management space. Integration and data management is really the place where the rubber meets the road. This is where the real work of integration tends to be done. Within this data management space, we have several components. User interface is the means by which consumers build integration flows and access data. User interface must support the full range of data consumers, from highly technical to tech novices. Considering the wide spectrum of data and integration stakeholders, the UI must be visual, intuitive, and adaptable to many different roles and skill levels. Data integration blends and harmonizes data from multiple disparate sources. It does this to produce useful, meaningful, and trustworthy data to be used for reporting, analysis, data science, machine learning, and automation. Data warehouses and data lakes are the most common targets for integrated data that's widely shared. Data scientists, data engineers, citizen analysts, and citizen integrators frequently need to produce integrated data sets tailored to their individual and specific use cases. Application integration implements sharing of processes and data among multiple applications in an enterprise. In doing so, they enable end users to access data and functions from independent and disparate applications through a single user interface. Disparate applications are common within an enterprise. Application integration is the glue, the essential stuff to design and operate business processes that span multiple applications. Data management includes data engineering, master data management, and reference data management. Data engineering organizes and processes large volumes of data, both structured and unstructured, to meet the goals for data quality and data accessibility. Data engineering is an essential enabler of modern business intelligence and analytics. MDM-RDM is the means by which organizations connect, reconcile, and quality assure their shared reference data. Integration patterns are an important piece of the HIP. They are the standard methods of integrating data and applications. Integration patterns are abstractions that describe integration processes without including the details of the data. ETL is a commonly used and well-known pattern, but it's only one of many patterns. Integration Hub is another common pattern that relies on publish and subscribe architecture instead of traditional point-to-point integration. Other patterns focus on application integration, data stream integration, APIs, message-oriented, B2B, and many more. Integration patterns are the templates upon which unique integration flows are based. Integration isn't possible without access to data and applications. Data ingestion and data application connectors. So data ingestion includes all of the processes that bring data into the data management ecosystem. The variety of ingestion methods can span a continuum from high latency batch processing to change data capture and stream processing. Data and application connectors are software components that encapsulate the protocols needed to connect with any kind of data, any kind of applications, regardless of structure and implementation technology, at any network location, and on any platform, whether on premises or cloud. Then we have the platform components of HIP. The platforms are among the challenges driving the need for HIP, multi-cloud plus on-prem, that are the understructure of data and application sprawl. Data sprawl is compounded by the variety of data types, ranging from relational to NoSQL and big data. Infrastructure platforms are the locations at which data and applications are deployed. Platforms include on-prem, cloud-hosted, including cloud-hosted data warehouses, cloud-hosted data lakes, and cloud-based software such as software as a service applications. Data is the raw material of integration. HIP supports any kind of data, structured, unstructured, semi-structured, and multi-structured. Data is accessible regardless of database type, which may be relational, NoSQL, geospatial, tagged data such as XML or JSON, delimited files, object stores, and much more. And believe me, there is more to come in data stores than what we know today with NoSQL and object stores. Artificial intelligence and machine learning, intelligence and metadata are an important part of HIP. AI/ML provides the intelligence in a smart HIP system, algorithms and machine learning that are used throughout to provide recommendations to integrators and to support automation and orchestration. Data catalog is a core component of data management that supports the capabilities for data integrators to search for data, understand and evaluate the data, and collaborate and share what they know about the data that they work with. When we think about quality, protection, and governance, it has to be built into the HIP. It can't be something external and parallel. So data quality and governance are fundamental to producing and delivering trustworthy data and trusted information. Quality management is hard when working with large volumes of data and unstructured data. Smart data quality management based on AI/ML overcomes many of these challenges. We have similar challenges with data privacy and protection. It's essential. We must do it. Safekeeping of data is a legal mandate as well as an ethical obligation today. Today's abundance of data includes lots of kinds of sensitive personal data. It must be protected, and data protections need to be built into the HIP. Metadata management is critical. It's the foundation of a data catalog and a unified data management platform that supports AI/ML, automation, and recommendations, tracking data lineage, tracking data usage, and much, much more. The combination of AI/ML with metadata management creates metadata intelligence, which is the foundation for powerful and adaptable integration and data management platforms. Just a brief Informatica mention, and Nassir can pick up on this later, but one of the powerful things that Informatica has done is build an engine that they call Claire, which combines metadata management with artificial intelligence and machine learning that is a shared AI/ML metadata management engine that is used by all of their products. So they are very, very strong in this critical foundation of metadata. So when I put all the pieces together, the HIP looks like this. HIP is the future of integration, and choosing the right HIP technology is a good beginning. But there are several organizational and cultural practices that you can put in place to maximize the value of your HIP. There are 10 of them listed here. Drive business value. Focus on the visible areas of business priorities. That's where you're going to get the value. Minimize the number of vendors and tools. Remember that seamless interoperability is essential. That's what gets us frictionless integration. Maximize the use of existing technology and skills. You already have existing integrators. You already have existing data subject experts. HIP isn't going to replace them. It's going to give them the tools to be more effective. Support all roles, all personas. Don't leave anybody out, from novice to tech savvy, from citizen to specialist. Support them all. Engage all the stakeholders, data stakeholders and application stakeholders. Involve them from the beginning, be aware of their interests, be aware of their needs, and that will take you a long way toward successful HIP implementation. Foster collaboration. HIP goes way beyond data sharing, supports shared integration processes, both data and application processes, and collaboration is one of the keys to sharing. Automate as much as is practical. Integration is complex, it's labor intensive, it's time consuming, but when the work can be accelerated through automation, you'll see substantial value from your HIP. Maximize reuse of APIs and connectors. APIs and data connectors are reusable components that help shift the data integration work and the application integration work from handcrafting to assembly. HIP can help you get over having many, many things that are reusable but rarely reused. Make data protection a high priority. Don't let the need for speed compromise the security of your data. And manage the evolution. Set goals, then measure, monitor, improve, define a few goals, bring a few things into your HIP, gain experience, gain knowledge, and then take next steps. So finally getting started, just a few steps. Hybrid and multi-cloud deployments are a permanent and irreversible reality of today's data management landscape. Hybrid integration is a critical piece of the data management puzzle. So the question is not if you'll implement HIP, it's when you'll implement. When you're ready to get started, take an organized step-by-step approach. Identify your HIP driving initiatives. These are business initiatives, digital transformation, or maybe technical initiatives, cloud migration, or maybe a mix of the two with IoT and streaming data. Identify the HIP components that you already have. These are often traditional data integration tools. Don't overlook the citizen-selected tools that often become an inherited burden for IT to support. Identify the gaps in your HIP components. So know what you have, know what you don't have. Remember that the gaps include both missing components and insufficient interoperability among the components that you have. Identify the right technologies to get a highly effective and sustainable HIP. Build HIP into your technology architecture and your technology roadmap. Identify and engage your stakeholders. And then plan and execute, make it happen. HIP is critical. HIP is the future of integration, both application and data integration. And with that, I'll pass back to Eric, and we can hand off to Nassir to talk about how Informatica implements the HIP.
All right, great job, Dave. I really love how you put all that together, and I think I love this HIP concept, and I think the future of integration is HIP. It's also trendy and cool. And with that, I'm going to pass it off to Nassir Khan. Nassir, you should be getting instruction now to take it away. Show us what you got, Nassir.
Thanks, guys. Thanks, Dave, for that awesome presentation. You went into some good depth around something that's becoming really hot in the market over the last few years, hybrid integration platforms. So I'll jump right into it. My name is Nassir Khan. I'm the Principal Product Marketing Manager for Informatica's iPaaS and hybrid integration platforms. So really, just reiterating through what Dave went through, what is HIP? Dave covered it really well, but to summarize it, HIP is really a holistic framework covering on-premise and cloud-based integration and data management, as well as governance. So the idea is really to bring together various tools and capabilities to streamline the entire data management process across this modern enterprise. And what are some of those building blocks for delivering this comprehensive HIP vision, this HIP platform that we're trying to build? As mentioned earlier in the webinar, they could include your existing on-prem integration tools like your ESBs or ETL tools, and then you pair those with your integration platform as a service capabilities that serve all these emerging and modern use cases, such as API lifecycle management. And of course, all these should be easy to orchestrate and deploy. And really, you want to be able to allow self-service across your enterprise. We are hearing this notion of integration strategy enablement teams or centers of excellence. Really, what we are seeing is pervasive integration across the enterprise. And what we're trying to do is enable integration in a more governed fashion so that you don't have, we've heard of application sprawl, we've heard of tech sprawl, there's also integration sprawl. So you don't want integration sprawl, you want to have the right technologies and tools to solve for the right problems. And you want to enable those different personas. So moving along, what are some of these driving factors, driving technology and application leaders in charge of integration infrastructure towards adopting this hybrid integration platforms? So, the modern business environment is becoming more complex with the proliferation of processes, there's different types of data, structured, unstructured, semi-structured, and whatnot. Applications, as we talked about, application sprawl. and really systems and users of that data. The reality is today is that we are rapidly moving towards a hybrid multi-cloud world. Pervasive integration across this modern digital landscape, as I discussed earlier, is a reality and really a necessity that provides this competitive edge. So in terms of different skills personas, we see that both citizen integrators, ad hoc integrators, and also specialists are embracing this self-service integration. Citizen integrators could include data scientists, your power users, and your business users and analysts, whereas those ad hoc integrators include your LOBs, your line of business developers, and other users at the LOB level. When we talk about transformation and modernization, digital transformation and modernization, they're happening at such a rapid pace. So hybrid cloud is really that new norm. And there is a push for cloud native solutions that offer all the benefits of cloud, like just in time, agility and flexibility, plus the transfer of the burden really of that infrastructure infrastructure management. You don't want to be managing that infrastructure. You want to push that burden to your vendor. So the current band of these on-prem integration technologies might really fall short in their capabilities to deal with some of these emerging use cases, like cloud data warehousing and cloud data lakes. And really, they hence need to be complemented with these new types of technologies like integration platform as a service. Now, let's take a look at some of the typical use cases. I wanted to talk about ground realities, what we see as a data management company. The ground realities that we are witnessing include things like, the use of hybrid cloud and multi-cloud is exploding. It's growing at an exponential rate. The push for, streamlined analytics supported by cloud structures like cloud data warehouses, then you need that connectivity. You need to be able to connect to various data sources on-prem, in the cloud. Companies might be migrating away from traditional on-prem data warehouses to cloud to kind of attain better flexibility and scalability and even time to value. And there's a need to support, as I mentioned earlier, those lines of business for self-service. And in some cases, companies are kind of augmenting their on-prem data warehouses with like a cloud data warehouse. So they might be bursting some workloads at certain periods of time into the cloud. So each of these use cases needs the right supporting ingredient or middleware to get to work effectively and in an optimized fashion. On the other hand, we look at application integration. As application sprawl takes a hold, there's a need for things like real-time integration and process integration. Applications are constantly sharing information to better, you want to be able to better derive meaningful information and insights. So you need those different types of applications to be able to connect with each other in a seamless way and to get real-time information and insights, because business today really is moving at the speed of, the speed of sound, I would say. With regards to app modernization and the use of APIs, we already understand that companies are rapidly moving from on-prem apps to cloud apps such as Salesforce or Workday and the myriad of more. They are also modernizing their legacy applications, right? They're getting rid of these monolithic services or tools they have and really adopting modular microservice architectures that are scalable and better manageable. Companies are also exposing their core services internally and externally through APIs, and there is a need for better management and control of those API services. Then we have many emerging use cases today, like IoT and getting IoT streaming data and making, getting real-time insights out of those. And then artificial intelligence, that relies on optimized data pipelines and quality data, because, garbage in is garbage out. So moving along, I wanted to talk about some of these things, Informatica's key capabilities with regards to a strategic HIP. So we have a comprehensive enterprise-grade platform over here. We are the only vendor that really supports both data integration on-prem, data engineering for your data scientists, data streaming, and also a comprehensive integration platform as a service for those new use cases. Then we talk about connectivity to any on-premise, technology or system, to cloud, to big data, to structured, unstructured, and semi-structured data. And this really is, I would say, a competitive advantage for us, because we talk about the depth, the breadth of our connectivity, and those are really unmatched. We also enhance our connectivity with artificial intelligence, so that based on the workload, we can, the connector can kind of optimize itself. Then we talk about metadata management and data catalog solutions, and centralized governance that are really a foundational capability. You want to be able to know your data lineage, where your data is coming from, who owns it, and things of that nature. Dave touched on CLAIRE and AI and machine learning, hyperautomation, and intelligent recommendations. We've inherently built artificial intelligence right into all our tools, and we call that CLAIRE. So we're one of the few vendors that uses metadata-based intelligence. We provide next best recommendations and things such as intelligent structure discovery. Today, you have so much data in the enterprise. We have a saying over here that AI needs data. It needs the right type and right quality of data, but that data also eventually needs AI, because there's such a ton of data out there that needs to be processed. A human being cannot potentially process it on their own, or without some kind of intelligent help. So we've kind of built that AI capabilities right into our product set. We talk about support for complex, multi-cloud and hybrid environments. So our technologies span on-premise, cloud, and that hybrid bridge. So the technology stack is optimized for all those kind of scenarios. And then obviously our iPaaS, which is really a differentiator for us, is modular, and it goes beyond those traditional capabilities of data integration and application integration. It goes much further. I'll talk about that a little later. And this goes without saying, your technology stack today needs to be high performing and reliable, secure, and scalable. So we built this technology with security in mind. Your data, your organizational data is critical. We've heard about all the data security issues over the last few years. So if your middleware, your core element, your tool, your recipe, your central technology is not able to provide you the security, around that data, then you really need to think about the technology set you're using. And that's so centrally we focused on security from the base up. We provide you with a single management and monitoring layer, a single pane of glass that we call for operational management. We call that operational insights. And this is great to manage your on-prem and cloud investments of Informatica. They provide you that, as I said, that single pane of truth. And they're great for capacity planning or capacity management and optimization of your entire integration landscape and technology stack. So I wanted to jump into our integration platform as a service that really supports that hybrid integration platform vision. So what are we looking at over here? When we talk about an integration platform as a service, it should be able to support any type of integration and really any type of data management pattern. Dave touched on some of these earlier: real-time, batch, streaming, and whatnot, and the myriad of others. So what we say is that at the core, the table stakes capabilities are your cloud data integration, connecting various data sources into your data warehouse, supporting batch and real time, and then your cloud application integration, connecting one app to another app in real time in an efficient manner, managing those APIs that you're building, right? And providing lifecycle management. The future is API, in my opinion, is API based. So you need the right types of tools and technologies to manage that API sprawl that's going to take place. And then I mentioned connectivity as a differentiator, right? The depth, the breadth, the AI capabilities of the connectors to be able to connect to any type of data source anywhere. But we go a step further. We talk about these new and unique patterns, including cloud B2B and the ones listed here. So if you want to like optimize your communication with your partners or streamline partner onboarding, you have something like cloud B2B. You want to make EDI communication more optimized. You want a cloud integration hub to do pub/sub models of your data models and your data. You want data quality, right? As I said earlier, garbage in, garbage out. So if you don't, have the right kind of tools to make sure you're getting the right data into your systems, then you really need to rethink your strategy. Cloud data preparation and cloud data catalog, understanding lineage, where's your data coming from, who owns it, that's critical when you're building your data warehouses or data lakes. Other things such as cloud master data management and data security, those are a given. And really governance, right? That's central to a comprehensive integration platform as a service. I want to end by, I want to end by giving you some next steps that will really help you on your journey towards, developing this HIP mindset and building your internal platforms. Your HIP platform, you want to download the analyst report. Eckerson has done a really good job on this. We have a guide to hybrid integration platforms. And more so, I also want you guys to try our integration platform as a service trials. We actually offer about 10 core services for trial, 30-day free trial. And they really let you start building your proof of concept from the ground up. So whether you're building a cloud data warehouse, whether you're trying real-time data integration, right? You want to try, your cloud B2B gateway to improve that partner onboarding. We offer that on a 30-day trial, and you can really build the POC. We give you all capabilities in there. So with that, I want to end. I want to open up to Q&A. I'll hand it back to Eric.
Sure. We have a bunch of really good questions, and the attendees must have been reading my mind, which I always love because I can use their questions instead of my own. One of the attendees asked, how does HIP enable workers to access data across multiple information platforms, think data warehouses, cloud big data environments, et cetera, to generate analytic results? And kind of where I'm going with this too is there are some new interesting ways of achieving federated queries. There's Apache Arrow out there, for example, but how does HIP handle that kind of environment? I'll throw that out to Nassir.
Ashu, do you want to take that if you're on?
Yes, I am. So let me see if I got the question right. The question was, how is HIP enabling organizations to manage better data, better in the places there it is, but still be able to process it, still be able to work with it, and still be able to run analytics on top of it? Did I get the question right?
Yeah, in other words, in these heterogeneous environments where you've got an on-prem data center, you've got a cloud big data platform, you've got multiple types of information systems, how does HIP enable the virtual reconciliation of these systems or analytics across those environments?
Excellent question. So the way I would approach solving that problem, which is very common to a large number of organizations, is because the data itself, we would want to keep it in its place where it is. What we want, trying to minimize in a HIP environment, is movement of large amounts of data over the network. HIP is uniquely, and especially HIP coming from Informatica, is uniquely positioned to be able to process, do integration, do analytics, right where it makes most sense for it. Using Claire, which is the AI ML based engine that Informatica has, we are well suited to understand the location of the data where it makes sense to process it in the best manner possible. The additional advantage of Informatica providing HIP is that both the on-prem and the cloud integration are available on the same platform, where without having to worry about the data movement, we can process the data as it exists in the place where it exists. And that's the beauty of Informatica HIP solution.
Yeah, that's very interesting. That seems to be also partially answering another question that came in from an attendee, which is how about integrating cross-functional processes virtually at the data level rather than integrating systems? Any thoughts on that?
Excellent question. So it's interesting because in the past we used to look at integrating processes. Now people are looking at integrating data, which is which as you can see shows the power of the data driving the processes as opposed to the other way. And again, going back to my point about the HIP platform coming from the organization that provides both the on-prem and the cloud on the same platform, we are uniquely positioned to process the data in the place where it makes most sense. Yes, there would be times when you would move the data, and we have the options, the deep technical options to move the data in the most optimal fashion. Whether that moves data in a push-down manner, whether that moves moving data in a bulk manner, whether that means processing data on a Hadoop cluster of some sort or a Spark on some sort. All of those possibilities exist on the Informatica HIP platform.
Yeah, this is very interesting, and I think that because you've taken such a comprehensive approach, that's why you can make these really bold claims. And I'll throw this one back over to you, Ashu. As I think about the complexity, and both Dave and Nassir did a great job of explaining that and really demonstrating the significant complexity that we face in the world of information systems these days. It seems to me that machine learning algorithms, they don't really care so much about complexity. They just crawl across these environments and find alignment. They find recommendations for how to stitch together different pieces and parts. And that's kind of what you have going on in the background, right? As machine learning is being used to identify patterns and make recommendations of integrations across different systems based upon what it's seen in the past. Is that right?
Absolutely. And the interesting part of using machine learning to improve upon the system is critical to how we have thought about the HIP platform that Informatica provides. It would not make sense for us to ask an integration developer or a citizen integrator, if you will, to go learn machine learning and advanced algorithms of AI just so he can get better sense out of the data. What we have done in the platform is to provide these functionalities, the AI and ML functionalities natively. So as you are doing your processes, as you are doing your integration, as you are profiling, as you are looking through and working through the data, the system itself is smarter now to provide you recommendations, to provide you insight, to provide you deep contextual nature of what you can do better as the information coming out of the data itself. And that truly tells me that the data is working for the AI, and going back to the point about that the AI is working for the data now.
Well, it's really cool too. I'm just guessing here, and I'm quite sure this is correct, that as a business user works with this environment, as this person is getting recommendations, that's also an educational process, meaning the user is learning more about his or her data, about the connections between these systems. And so it's not just that a job is getting done, it's that a job is getting done more efficiently, and the user is getting better at doing that job. Is that right?
You got it. And now people are finding things that they did not even know. They did not even know where to go look for and how to find them. And that truly is the power of CLAIRE and the AI ML engine that we are building into various aspects of this platform, which is where the system itself is finding things that the person who is working on the system did not know about, or did not know how to ask those questions. And that is where truly the power of the Informatica platform providing the HIP integration truly shines through.
Yeah, that's great stuff. We have a lot more questions here, folks. I'll pass these on to the presenters after our webinar ends in just a few minutes here. But there were a couple questions around data governance, for example, and data access. And governance and access kind of go hand in hand. I'm guessing that CLAIRE in these environments can also make recommendations on data governance. Is that right?
That is correct. Our governance solution is also built on the same platform, leverages the same power of AI and ML, shared intelligence across all the solutions that are coming out of the platform. So absolutely 100%, the shared intelligence is available on the governance solution as well.
Yeah, and metadata, you talked about that for a couple of minutes earlier. You are able to collect and analyze metadata across these heterogeneous environments, right? Which I'm guessing is a core part of the process that you talk about of natively being able to facilitate these connections. Is that right?
Absolutely. So what we have done as part of the platform, and this is a core functionality that's available on the platform, on the Informatica platform, is ability to capture all kinds of metadata. The traditional metadata that everybody is aware of, which is coming from flat files and databases, relational databases and column headers and things like that, but even goes beyond that. Now we are able to access metadata from semi-structured, unstructured, and all kinds of possibilities out there that are available for the data. Informatica is able to capture all of that metadata, bring it on the same platform, and power of that platform ability to do deep analysis, doing AI and ML on that metadata provides us ability to provide back to the user that deep insight, that those deep recommendations that we as Informatica can uniquely provide.
Okay, good. Another attendee is asking where can they get more information, free information about the functionality in the platform, how it works, how they can get it all rolling. Where's a good place to go?
Please do visit Informatica.com, and from there you would be able to navigate through the details of what the platform provides, or feel free to reach out, drop us a line through the links available on Informatica.com for one of us to connect with you.
Okay, good. And I'll throw one question over here so Dave doesn't feel lonely out there. There's so many over at Ashu, but they're really good technical questions. But Dave, I get very excited about this because now we have this whole world of opportunities and we have the machines working for us. I think for many, many years in the IT world, the humans were working with the machines, but kind of working against the machines to a certain extent. And with AI, especially as pervasively deployed as Informatica has here, I feel like that table has turned, and now the machines are really working for us and helping us stitch this all together, and kind of just in time because of that complexity. But what do you think about that, Dave?
I think that's very true. For so long, people working with data tended to be the shoemaker's children, and we've seen that shift, and we're starting to apply technology to data management in ways that we never have before. I like the line about AI needs data, but data needs AI. In fact, that's some of the message. I have a report out on Eckerson.com called Self-Driving Data that draws some parallels between what we're trying to do with self-driving vehicles and what we can be doing with AI, ML, and data management. And I believe at this point, we've just scratched the surface of what's possible with AI and ML for data management. And Informatica has a good roadmap for it. And I would say their Claire engine is probably one of the more cutting edge approaches to using AI ML for data management in the industry today. But I think we'll see more and more to come of putting the technology to work for data management, putting the technology to work for application management, putting the technology to work for integration. We'll see that continue to grow rapidly over the coming months.
Okay, good. And right before we go, the clock is almost at 3 o'clock Eastern now. I'll throw one last question over to Ashu, and this is my holy grail question, Ashu, so prepare yourself. One of the attendees asked it, but in my mind, the holy grail has always been some sort of AI machine learning engine that can scan your existing ETL processes, all of those batch windows that you're hitting, in some cases hundreds and thousands of them, and slowly but incrementally or perhaps even quickly reconcile them, optimize them, and import them into a new system like HIP. Is that possible today, or are we still moving towards that?
So that's an excellent question, and my short answer is yes. We do have tools and technology and how tools that are available to transition traditional customers who are in old ETL, DI kind of routines into the new HIP model. But I would caution that it's a journey. It takes effort on both the tool side as well as from the practitioner side who is trying to put that together. There is not going to be a magic button. I'm not going to lie to you, but it's part of learning of both the tool that's improving upon the AI and ML and the technology behind that, but also on how you approach HIP as an organization's best practices itself. So the short answer is yes, but there's not going to be a magic button in reality. So I'll leave the answer with that.
Well, that's good. This is all good stuff. Well, folks, we burned through an hour here. We do archive all these webinars for later viewing, so by all means, come back later and check all that out. We're going to bid you farewell, and we'll catch up to you next time, folks. Take care. Bye-bye.